Kite is another type of quadrilateral. It has two distinct pairs of congruent and adjacent angles. Quadrilateral A, B, C, and D is a kite. In this kite, lines AB is congruent to line AD, and lines BC is congruent to DC. The two segments, namely line AC and line BD, are its diagonals. There are two theorems that concern kites. The first one is Theorem 4-23. It states that if exactly one diagonal of a quadrilateral is the perpendicular bisector of another diagonal, then the quadrilateral is a kite. For example, lines AC is a diagonal of a quadrilateral ABCD. Then line BD is perpendicular to line AC. Therefore, quadrilateral ABCD is a kite. The second one is Theorem 4-24. It states that if a quadrilateral is a kite, then its diagonals are perpendicular. Let's take this one as an example. Quadrilateral ABCD is a kite. Then therefore, line AC must be perpendicular to line BD, so that this quadrilateral will be a kite. Another theory that concerns kite is Theorem 4-25. It states that the area of a kite is half the product of the length of its diagonals. Let's take this kite for an example. The formula for the area of the kite is 1/2 times the line measure of line BD times the measure of line AC. Take this one as a proof of Theorem 4-25. A ratio is a comparison of two numbers by division. Given two numbers A and B, wherein B is not equal to 0, a ratio is a quotient A divided by B. This ratio can be written in three ways. As to A to B, the second one is A to B with the use of a colon, or A to B with the use of the division sign. Each of these ratios is read as A to B. As an example, in the figure, point C is between point A and B. If the distance between point AB is 12 centimeters and the distance between point C and point B is 4 centimeters, find the ratio of CB to AB. The solution: CB over AB is equals to 4 is to 12. In answering this one, we must lower this one to its lowest terms, which is 1 is to 3. Notice that the ratio 4 over 12 was written as a fraction in lowest terms. The ratio 1 is to 3 can be written as 1 is to 3. With the use of a colon. Proportion. A proportion is a statement of equality between two ratios. In symbol, A is to B is equals to C is to D, or A is to B equals C is to D with the use of a colon, wherein B is not equal to 0 and D also is not equal to 0. Each number in a proportion is called a term. For this one, this is the first term, B is the second term, C is the third term, and D is the fourth term. The second and the third terms are called the means, and the first and the fourth terms are called the extremes of the proportion. This proportion is read as A is to B as C is to D. Example, find the missing term in the proportion 4 is to 5 as x is to 15. The solution: 4 is to 5 is to x is to 15. What we will do is to cross multiply the terms. 5 to x and 15 to 4. 15 times 4 is equals to 5 times x, or 5x. The resulting would be 5x is equals to 60. We multiply both sides by 1/5, and therefore x is equals to 12. Then 12 is the missing term. Laws of proportion. In geometry, proportions are very useful in solving problems involving lengths of segments. It is often necessary to rewrite a proportion into its equivalent form. This can be done by using the laws of proportion.